So next up, we are going to be spawning our asteroids. So when it comes to spawning asteroids, there are a couple of ways to do this, but I do want to do this in the most basic manner possible so we can really focus on the basics of how this works. So I think the most basic way to do this is to have our asteroids spawn on the outskirts of our screen. So let's say this is an asteroid. I want it to spawn randomly from either the top, bottom, right, or left-hand side of the screen. But they need to be completely off the screen as they spawn. So we're going to push it all the way off to the left. Basically, if they're off to the left, we're going to be giving it a velocity that moves it over to the right. So we could give these angles that move them from the left towards the right at an angle. But the most basic way is to just have them travel up, down, left, and right across the screen. That's what we're going to be doing. Just try to make this as simple as possible. Still going to be a fun game even without the angles. And if you really want to take this further with angles, it's something you could definitely do using this knowledge on your own. But let's make this the basic version where our asteroids come from the left, right, top, and bottom, just in a straight direction. So how do we begin even spawning these asteroids at a specific rate? Well, we need some sort of time management method. And there are a few time management methods within JavaScript. One is we could use setInterval. That's just a simple function that calls itself at a particular interval, such as 2, 3, 4, or 5 seconds. We can determine the time, doesn't matter. We could also use a delta time, which is where we actually determine how much time has passed between frames, as we call request animation frame. And that probably is the most robust way to do things, but it's definitely not the simplest because we need to understand how time differences work as frames go by. And I really think the most simple method is to use setInterval. Don't worry, I've done this on a few of my games myself, and it's totally viable as long as we take into account one or two pitfalls that might come about due to using setInterval. But let's use the setInterval method. I think it's going to be good with that. So how do we create an interval in which we start spawning asteroids? Well, we'll start by calling a setInterval method. And this comes from our handy window object like so. By the way, if you don't want to use window dot, you can just get rid of this altogether. The window object is pulled in automatically, so you can use all of its methods without calling window dot. But it is kind of handy to use window dot anyways if needed to really understand where these methods are coming from, especially if you're new to this. So setInterval takes two arguments. The first one is going to be a function. So I'm just going to put in a basic arrow function right there. And then the second one is going to be how often do we want the code inside of this arrow function called? At what interval do we want it called? Well, I want an interval of about 3 seconds. So every 3 seconds, we're going to have an asteroid. And I want to put in a value of 3000 right here to represent 3 seconds. This is 3000 milliseconds, and if my math is correct, 3000 milliseconds is equal to 3 seconds. I'm so smart, I know. So we're going to call this an interval of 3 seconds, but what exactly do we want to call? Well, let's think of how we are pushing in projectiles into our projectiles array. Whenever we press space, we are adding in that projectile. And this kind of resembles that same functionality. Instead of pressing space though, we are just calling this method right here, which should be adding in an asteroid to an asteroids array. So draw the parallels there between adding in projectiles and how we're about to add in asteroids. We need some sort of array to hold our asteroids. Therefore, I'll create a const called asteroids and set it equal to an empty array. Now, whenever we call the code inside of here, we want to grab that array and push in what? Well, a new asteroid. What does a new asteroid take? I don't know, because we haven't created it yet. So let's create that now. We have our class of projectile, which is just a basic circle. And if we think of what an asteroid is, the most simplified version is a basic circle. So we could extend our projectile class, but it's a little, I don't know. I don't always like extending things because sometimes the abstraction leads to a lot of problems later on. I think the simplest way to do this is to just duplicate the class, even if it's going to be so similar. It's totally fine in this case. Nothing's going to go wrong. We're not going to have performance issues, but just know, if you would like to extend this using inheritance, you can. I'm not stopping you. So I just duplicated that class of projectile, and I'm going to call this class of asteroid instead. I definitely want a position, I definitely want a velocity, but our radius, that's a good talking point. What size should our asteroids be? Well, we definitely want them larger than a projectile. So let's add a 0. They're going to be 50. Or should they be variable? Should every asteroid be the same size? Should they be different? If we want them different, then we can multiply this by math.random. So math.random gives us any value 0 to 1 randomly. And if we multiply a value of 0 to 1 by 50, we're going to get any random value 0 to 50. But that means we might get something very, very small, like a value of 0.5, a value of 2, 3. Those are very small asteroids. I always want these to be bigger than something like 10 pixels. And if that's the case, we can add on 10 to this right here. So now we're going to get any value 0 to 50, and then we're going to add on 10. This effectively gives us a size anywhere from 10 to 60, which is great. I think that's perfect for the size of our asteroids in which we're about to deal with. But an asteroid, I really wanted to go off of the original game where they have a stroked outline, not a filled in outline. And if that's the case, yes, I want to keep our arc code, but I don't want to use fill style, but rather stroke style. And I'm not going to fill this in anymore. I'm going to stroke it, and that should give us the outline we want for our asteroid. Update is going to be exactly the same, so looking to be in great shape right here. Now we're going to push in a new asteroid that takes a position. That's an object with an X and a Y. I'll do 0, 0 to start for both of those. We're also going to have a velocity, also equal to an object with an X, and then a Y. So we need to determine where these asteroids should be placed dynamically. And they're going to be placed randomly, either on the top, left, bottom, or right-hand side of the screen. We'll get there very shortly. Let's just make sure these are being rendered out on the screen and moved over to the right. So our x velocity is going to be equal to 1. They're going to be spawned at the top left-hand position right now with a position x and y of 0. And really, we just need to render these out the same way we rendered out our projectiles using this for loop. So yes, we are going to be removing asteroids from the screen. And if that's the case, we want to loop from the back. So I'm going to simplify this as much as possible. We can even add a comment that says this is asteroid management. And if we're managing our asteroids, we no longer want to reference our projectiles, but rather our asteroids. And by the way, remember, I copied this from above. I just want to make sure we're absolutely clear on that. And we're looping from the back of our asteroids array. So now we're grabbing one individual asteroid, and we can rename this. We can actually keep it the same. This is totally arbitrarily named, but it makes way more sense to call this one particular asteroid, which we're looping over. And then we are calling that update method on that one asteroid. Let's see if this works. Every 3 seconds, we should get a new asteroid. I'll save, refresh. We should start seeing asteroids spawn from the top left. And there is 1. There is 2. We have a little weird fill style going on right there. We'll be able to fix that pretty shortly, I would say. But you can see these are different radii. That's awesome. That's definitely what we want. But we need to make sure that they're spawning in the correct locations and going in the correct directions. So how do we determine randomly where these should be spawned? Well, we're going to do so within set interval. And really, we want 4 options. 4 random options in which we can choose to determine whether it be top, left, bottom, or right. How do we get a random option from a value of 4? Well, we can use math.random. Remember, that gives us any random value 0 to 1. But if we multiply this by 4, now we have any value 0 to 4. But this produces floating point values, such as 0.5, 0.6, 1.2, whatever it might be. And that is not a valid index. So we need to make sure that we floor this value with math.floor. All this means is we are rounding down from whatever math.random times 4 might be. So if we get something like 0.33, we're rounding down to 0. If we get something like 0.35, we're rounding down to 3. And now we have the option to get essentially any number 0 to 3. Perfect. So I'll declare that this is going to be our index. And now we can use a switch case that switches out this index with particular cases. Let's say case 1 is equal to 0, and then we break out of it. Our case of 0 is going to be left side of the screen. So if we randomly get 0, this means we want to spawn it on the left. How do we actually spawn our asteroid over there on the left? Well, we could grab this code and paste it inside of our case statement, or we could declare some lets, such as x and y. And inside this case, alter these x and y lets. So where would we want to place our asteroid so that it's off the left-hand side of the screen? Well, we would say x is going to be equal to 0, but our asteroid x is going to be the center of the asteroid. And if that's the case, well, part of it might still be showing within the screen on spawn. Therefore, we need to subtract our asteroid's radius. So our asteroid's radius is only there when we actually create the asteroid. It should really be determined right here whenever we try spawning a new one. So let's grab where we are declaring that radius, which is right here. I'm going to grab the whole thing. And then instead, I'm going to pass through a radius property. And then set this .radius equal to the property we're passing through when we create a new asteroid, which is down here, right on line 125 for me. So we're also going to have a radius. And the radius is going to be equal to 50 times mathrandom plus 10 gives us any value 10 to 60. So now we have a random radius ready to go. And we want to say that this random radius, when we spawn something off the left-hand side of the screen, we need a value of 0 minus that random value of radius. That's going to give us the right side of our player and push it off the screen completely to the left. And with that, things should be looking and working pretty well as long as we're passing this radius through into our new asteroid as we push in a new one. But we need to take into account basically the y-axis as well, because right now when we push in a new asteroid, we only have a static value of 0. And since we're over here, remember, we're setting x equal to 0 minus radius if we get a case of 0. We want to make sure that we assign our position x equal to whatever this is assigned to right here. So I'm getting rid of 0 with position x when we push in a new asteroid and replacing it with this new dynamic x instead. But we don't want our asteroid to be spawned at a y of 0 near the top of the screen. We want it in a random position from the top of our screen to the bottom of the screen. Which means if we get this case of 0, the left side of the screen, y needs to be anywhere from 0 to our canvas dot height. How do we get that value? Well, we can take math.random and then multiply that by our canvas height. This will give us any value 0 to the canvas height. Looking great with this. So really all we need to do in this case for the left side of our screen is replace this static 0 with y. And then what is our velocity going to be in this case? Well, it is going to be x equal to 1. Y is not going to be moving at all. But we do need those velocity values. So I'll declare two lets up here, vx, vy for velocity x and velocity y. Vx will be equal to 1, and then vy will be equal to 0 when we get this case of 0. So let's reference velocity x and put in that dynamic value, and then put in the dynamic value for y as well. So this is pretty much close to the same as what we had prior, but the difference is when we start adding in more cases, we can change these 4 variables to change the location of where these asteroids are spawned, and then to also change the velocity in which they're moving. So are they moving to the right, left, down, or up? That's basically what we're doing right here. We just need to add in those other cases. So let's do that now. I'm just going to copy and paste case 0 3 times. And it looks like I messed that up a little bit. Let's try it again by adding in a line break. And now we have a new case, not 0, but rather 1. And 1, I'm going to say, is the bottom of the screen. Doesn't really matter which we declare, but I think that makes sense to go counterclockwise. And then we have another case of 2. This will be the right. And then we have 3, which will be the top. So now we just need to determine where our asteroid should spawn if we get a case of 1, which means it spawned on the bottom side of the screen. Well, we want it to be spawned anywhere on the x-axis, 0 to the canvas width. Therefore, we'll get math.random for x, and then multiply that by our canvas width, like so. And what should our y be? Well, we want it spawned off the bottom of the screen. So we will get our canvas height, because that is the bottom. but we want to add on to this the radius that we're determining randomly up here. And as long as we do that, it should be placed off the screen perfectly. But we don't want to be moving left or right here. We want to be moving upwards. So Vx will be 0, while Vy will be -1. Should be all we need to do for when we get a case of 1, meaning they're spawned on the bottom side of the screen. So now we have the right side of the screen. How do we determine this? Well, x should be our canvas width plus our radius. So let's do that. Let's get our canvas width plus the radius that we generated up here. And what should y be? Y should be the exact same as we see here. Math random times canvas height means it's going to be spawned in any random location from the top to the bottom of our canvas. And then it should be moving to the left. So our Vx should be -1, while Vy will be 0. Finally, we have the top side of our screen, and it might just be easier to grab the bottom side of the screen, these 4 lines right here, and replace these 4 lines with those 4 lines. Because this way, we could say that our x-coordinate should be completely random from 0 to our canvas width. We already have that set. And then our y isn't going to be canvas height plus radius, but rather 0 minus radius. It's going to make sure that our asteroids are always spawned off the top of the screen. Now, if I want this to move downwards, then we need to make sure that Vy is equal to 1. We don't want it moving left or right, so Vx will be equal to 0. We want to save this, and remember, all these values will be stored as a new asteroid is pushed into the game. If we did everything correctly, it might take some debugging on your end. Everything should work. If things don't work correctly and you just can't find out what went wrong in your code, be sure to check out the GitHub gist snippet that I've included. It has all this code, which you can just copy and paste, and compare your code as needed to see what went wrong and what you might need to change. But let's test this out. I'm going to save this, go to our game, refresh, and there is one asteroid. Wrong color still, but it's there. And there is another one. Perfect. We have more coming in. All looking really good. We had one coming from top and left. We have one coming from the right. And I have no doubt one from the bottom is coming. There it is. So all of our asteroids are coming in correctly, completely randomly. But we're not done just yet. Let's fix that annoying red asteroid that's coming in immediately from the start. So where is our fill style of red anyways? Let's find out. I'm going to search for a string of red. And it's happening right here with this arc. So I never actually called c.beginPath, and that's always a good idea when you're dealing with arcs or lines. And I never called c.closePath for this arc. Let's do that now and see if it fixes the issue. Just going to save, refresh. And we should see an asteroid come in, and yes, that immediately fixes it. Perfect. So that's all we needed to do to fix that, but we do need garbage collection to make sure we're removing these asteroids as they go off the screen. So we're going to be doing this very similarly to how we did garbage collection for our projectiles down here within our animation loop. Now, since our asteroids are already being spawned off the screen, well, we can't really remove them immediately using the same condition that we have up here for projectile, but we can do it very similarly. So I'm going to grab this code that removes projectiles if they are off the screen, and I'm going to place it within our asteroid management loop. So right here. Now, all I need to do to change this up so that it works for asteroids is select every location in which we're referencing a projectile. So 1, 2, 3, 4, 5, 6, 7, and 8. I'm going to grab those 8 locations, which I'm doing with Sublime Text, by the way, by selecting one character or one word of text, and then hitting Command D. So when I hit Command D, you'll see it highlights a new one, and I can keep clicking it or pressing it to get that next version of the word. So now I can delete that text and type in 8 instances of asteroid, which we're referencing up here. So now this should work for our asteroids, but we need to make sure that we're splicing these out from the asteroids array and not the projectiles array. Otherwise, things definitely aren't going to work if we try splicing out a projectile when an asteroid is off the screen. We don't want that. So let's just make sure you're splicing out the asteroids. So save this, refresh, and let's see how things work. There is one asteroid. Looks good to me, but we want to console log this out to definitely make sure this is working. So whenever we spawn an asteroid, it's going to be right here within set interval. I want to console log out our asteroids array to make sure that this decreases over time as our asteroids go off the screen. So let's see it in action. We have one asteroid right there. We have two. We're going to have three, but when one of these goes off the screen, it should decrease. So one went off, and yes, these are definitely decreasing over time. And yeah, you can see as they continue to go off the screen, they just get removed automatically. So with our asteroids being removed correctly, they're being spawned, they're moving across the screen, I think we're going to be in good shape with this. So I really recommend experimenting with this. Start randomizing the radius of your asteroids more. See if you can actually change their angles on your own to get them going in different directions rather than up, down, left, and right. And then, yeah, I think that's going to be pretty good for what we see right here. So with this, we'll be able to go back on over to To-Do and check off Spawn Asteroids.